So, welcome you all in the sixth lecture of Electronics Measurement and Instrumentation. I, Dr. Indu Prabha Singh, Department of Electronics and Communication Engineering, Sri Ram Swarup Memorial College of Engineering and Management, is here to discuss the digital multimeter and the different probes used in digital multimeter. So, we will discuss digital multimeter, what is the function of digital multimeter, what it measures and how we can utilize it, and we will also discuss the different probes that are used in either in digital multimeter or in CROs. So, multimeters we can see are of two types. What is multimeter first? Multimeter are the instrument by which we can measure different quantities, like we can measure AC/DC voltage, AC/DC current, we can also measure the resistance of the any unknown value of the resistance, and we can, apart from this, there are so many multimeters by which we can measure the frequency of a circuit. We can also find out whether the diode or the diode or the transistors are in working state or not, or this is the faulty component or not. So, we can see the multimeters are of two types, one is analog multimeter, another is digital multimeter as shown in the diagram. In analog multimeter, the first multimeter that is shown here is the analog multimeter. So, we can see in analog multimeter the value of the unknown quantity is shown by the deflection of an needle. So, there is an deflecting needle and or we can say the pointer, and there are so many scales as you can see in the diagram. There is AC signal, AC voltage measurement for up to 1 volt, or if we want to measure more than 1 volt, then there are 10 volt. Then similarly, the milliampere range is there and the ampere range is there. There are so many, there is a selecting switch by which we can measure the different value of the voltage and current. So, if we can see in the diagram that there is a 10, 50, 250 and 1000. So, we can measure from millivolt to 1000 millivolt using this instrument. So, suppose we want, and whenever we measure any voltage or current, then the first thing that we have to put this selector switch as the highest position. If we will not put this at the highest position, suppose we are putting this knob at 10 volt and suppose we have applied 200 volts. So, what will happen? That will damage the instrument. So, whenever we want to measure any voltage or current which we do not know what is the value of that voltage or current, so we will put the selector switch at the maximum position. So, suppose we are measuring this by putting at the voltage of 1000 volt, but it is showing very less voltage, suppose it is showing only the 55 volt. So, to get more accurate value, we will put this switch at the 250 volt. So, it will give the more accurate value. So, this instrument has a problem that this is an analog instrument. So, when we have some errors during the noting down the values, then we have a parallax error over there. So, that is why the analog instrument is not much preferred. So, we are having digital instrument. So, digital instrument may again we can see that there are different ranges and there are one common terminal, and then there is a terminal that has milliampere range voltage and ohm, that is resistance we can measure. If the current is more than 1 ampere, then we will put our knob at this position. So, we can measure different values as we have already told. I have already told that AC/DC voltage, AC/DC current, resistance, that is the minimum requirement of a multimeter, but we can measure many more other quantities also. So, if we can see, these are the digital multimeters. So, these are known as probe or leads. So, suppose if we want to measure a common current, that means a current we want to measure that is of an electronic circuit. So, we know that in electronic circuit there is not much current, current is less than, always less than 1 ampere, it is in the milliampere or the microampere. So, we will put our knob at this position, this is probe or knob. So, we will put knob at this position, generally red lead is used for the signal unknown quantity, and black lead is used for the common purpose. So, for the grounding purpose. So, we have put this black at the common terminal and red at this position, and then again what I have told ki we will always measure any quantity by putting the knob at the highest position. So, suppose we want to measure the voltage. So, we will put the highest position voltage if we do not know what is the range of the voltage, what is the value of the voltage. And then there are so many things on this knob. We can see that there is a AC voltage measurement that is shown as sinusoidal waveform, there is current measurement, resistance measurement, then there is DC voltage. So, we can put the knob if we want to measure AC current, then we have to put the knob at the AC current or AC voltage position. So, when the current value is much less, we will put the position of the knob is at this leading lead is at this position. But suppose the current is high, suppose we want to measure high value of current, suppose it is an electrical circuit and we want to measure high value of current. So, we will put the red terminal, that is the red probe is at this position and we will measure this. So, as we can see that this instrument is showing the value of 128.7 volt. So, here in generally in digital multimeter there are these 3 digits vary from 0 to 9, but the 4th digit, that is 1, it will have only 2 value that is 0 and 1. So, here we can vary this voltage from 0 to 9, these 3, but this digit will change only to 0 and 1. So, it means by this instrument we can measure the voltage voltage from 0.001, that is we can measure the minimum value of voltage, that is 1 millivolt, and maximum is 1999. It means ki 199 volt we can measure by this instrument. So, this instrument is known as 3.5 bit instrument. So, because it measures 3 complete value and 1 only 0 to 1. So, this is known as 3.5 digit multimeter. Similarly, we are having 4.5 digit multimeters, and nowadays there are multimeters which can which can represent the value of whole digit. That means, this value also changes from 0 to 9. So, this multimeter is known as 3.5 digit multimeter. Similarly, we have 4.5 digit multimeter, 5.5 digit multimeters. So, multimeters having more digits will have high resolution, because it can measure the minimum quantity. So, these are the technical specification when we purchase any multimeter. So, these are the technical specification given by the supplier. Suppose here is a digital voltmeter, this is a multimeter. So, it can measure the digital it can measure the DC voltage from 100 millivolt to 750 volt, and it has a resolution of 0.1 millivolt for the lower range. So, we can measure 0.1 millivolt from this particular instrument. Then accuracy is plus minus 0.3% of the reading. So, the accuracy means ki how close our value is the true value. So, it means ki there may be a tolerance, or we can say the error of plus minus 0.3% of the reading. Similarly, we can measure the voltage, AC voltage, we can measure the DC current, and the range is given. So, here that for DC DC current 10 milliampere to 10 ampere we can measure, and the resolution is given. So, every manufacturer who manufacture any instrument, they always provide the technical specification for that instrument. So, similar is with the digital multimeter, they provide what capacitance value we can measure, what the frequency we can measure, and so many things is given. So, now types of digital multimeter. So, first one is flux multimeter. So, this multimeter is designed with various collaboration functions, the type of multimeter available from advanced features to measure humidity, duty cycle, pressure, frequency, temperature. So, apart from measuring voltage, current, resistance, it can also measure the humidity, duty cycle, pressure of any pressure measurement it can do, it can measure the frequency, it can also show the temperature. So, in this instrument the range selection is not done, not required to be done, it is automatically selecting the range. So, the problem of range selection is not here, and similarly they are using a fuse to protect the damage of instrument. Suppose if supply voltage suddenly increases, so it will adjust the value of that, and if the value is not adjusted, then if suppose a very heavy current flow, then the fuse circuit will protect this instrument from the burning. Then there is clamp digital multimeter is also there. So, if we want to measure the current by using any multimeter, so this clamp multimeter is a very good device for that, because we do not need to have to measure, to break the circuit to measure the current. So, we will put this instrument terminal between the wire is put between these these part. So, what will happen, it will directly measure the current. So, and for the voltage measurement and other quantity measurement, there is two terminals are given. So, by using probe circuit we can use the other values, but the current we can directly measure by just putting this multimeter across that wire. So, this instrument is generally used by the professionals. So, there is also many instrument, that is auto ranging multimeter is also available in the market. So, in auto ranging multimeters we have a knob at the center, and again there is no need to select the range of the voltage or current measurement. It will automatically select the range and it will automatically give the value. So, this is very good instrument for the beginners or for the electricians or the person who does not know much about the multimeter. Here we can see that we have discussed that there is multimeter that has 3.5 digit, 4.5 digit, but we can see this multimeter has 4 whole digit. So, there is no concept of having 3.5 or 4.5 digits. So, there is variety of multimeters available in the market and they can measure variety of quantities also. This is the block diagram of a multimeter. So, in multimeter when we want to measure any suppose resistance, so generally the multimeter is measuring the voltage, and if we want to measure the current through that multimeter, so what we will do, we have to convert that current into voltage. So, we know that V is equal to IR. So, V is equal to IR. So, if we want to measure the resistance, then what we will do, we will just have a constant current source. So, if I is constant, so V will be proportional to R. So, we can measure R in terms of change in voltage by keeping I constant. So, basically we are measuring the voltage difference, but it is in terms of R, resistance. So, if we want to measure resistance, we have to need a constant current source, and the instrument, the display system is calibrated in terms of resistance, although it is showing voltage. Similarly, if we want to measure current, then again we need a voltage drop across a resistance. So, we need a standard value of resistance for this purpose. So, suppose there is resistance, there are a selector switch, rotary switch that selects the value. So, we can see that there is first value, that is resistance, it measures resistance. When we keep our switch at this position, it will measure resistance. When we keep at this position, it will measure the AC voltage. Similarly, AC current knob, DC current knob and DC voltage knob is there. So, when we want to measure a resistance, then we will keep our switch at this position, and here we can see that there is a current, constant current source. So, I have discussed we have to measure the resistance in terms of voltage. So, there is a constant current source, then it will pass through and buffer amplifier. So, again in every instrument we need either the attenuator or the amplifier circuit. So, every selector, after every selector switch there is an attenuator and amplifier also. So, if the signal amplitude is very weak, we need an amplifier circuit to amplify that signal, and if the signal amplitude is very high, we need attenuator to clip off the voltage, to reduce the voltage. So, and this constant current source output is fed to the buffer amplifier. So, buffer amplifier is basically an amplifier which whose voltage gain is 1, but what is the benefit of buffer amplifier? That is, it provides very high input resistance. So, because of this high input resistance, this multimeter will not load to any circuit, loading effect is not there. So, because of loading effect the measurement is not proper. So, this is passed through the amplifier, and again there may be a block of amplifier or there may be a block of attenuator as per our requirement, and then it is fed to the analog to digital converter circuit, because we are using digital multimeter. In analog multimeter we are not using this particular circuit, that is analog to digital converter circuit, because there is no need of conversion of analog signal to the digital signal. So, previously I have discussed the analog multimeter. In that circuit this block is missing and all other blocks are there. Similarly, if we want to measure the voltage, so if the voltage amplitude is very low, then again we need an amplifier circuit. If the amplitude is very high, we need a attenuator circuit. So, what is in attenuator circuit? Basically we use a parallel combination of resistance and capacitance. So, again if there is an AC current, since our meter is only measuring the DC voltage, so we have to convert it into DC. So, we need a rectifier circuit. Generally full wave rectifier bridge circuits are preferred for this purpose. So, this calibrated the current voltage, which is if has high value, then it is passed through the calibrated attenuator. If it has low value, then it will pass through the amplifier, and then it is fed to the rectifier circuit. Rectifier circuit converts AC into DC, and then it is fed to the analog to digital converter. Similarly, if we want to measure current, then again the current is converted into voltage, because basically we have to measure the voltage. So, again for the conversion of current to voltage, either we need the op amp circuit that converts the current into voltage, or we can simply use a resistance, a standard value of resistance, and we can measure the voltage drop across that resistance, and that the voltage drop is proportional to the current flow. So, there are the ways to convert current into voltage. Then again, since it is AC signal, we need a rectifier circuit to convert it into DC. Similarly, if we have DC voltage, then we directly fed to the analog to digital converter. There are so many analog to digital converter circuits you have studied, like a successive approximation circuit, integration type of circuit, dual slope analog to digital circuit, converter circuits are there. Then there are a digital display, that is the 7 segment display. As we know, there are 7 segments, 1, 2, 3, 4, 5, 6, 7. So, it can display from 0 to 9. Suppose 0 want to display, then this LED will not on. If we want to display 2, then this and this LED will on, and others 2 are in off state. So, this is the basic function of the digital multimeter. Here we need input probes. So, that probe is basically used to convert, that is using this attenuator at this position, we can use the attenuator at the input probe also. So, then probes are of many types, we will discuss in this lecture also. Then what is the advantage of multimeter? So, first of all, it gives automatic output display. We do not need to write down the reading, because it is not having a analog output display. So, we do not need to note down the readings. So, there is no parallax error and other things. So, it is automatically displaying output, and there are so many multimeters that we can connect it with the storing memory devices. So, we can store this the values of the multimeter, and we can also sync it with the PC. Then it is more accurate value because the output of this meter is not depending upon the battery life or the battery. So, and the accuracy is very high because there is no what can say parallax error or other type of error is there. So, and multifunctionality is 0, 0 adjustments are not required, and so on. So, disadvantage of digital multimeter, it is expensive with respect to analog circuit, and if there is a fluctuation, then it will not properly measure the voltage or current or any other things. So, as I have already discussed, the multimeter application, temperature, environment application, we can measure temperature, we can measure humidity, we can measure high low voltage, DC voltage, peak to peak voltage, we can measure RMS value of the voltage. Similarly, we can measure current, resistance, time and frequency. So, there are different type of multimeters available in the market. As per our requirement, we can purchase it and we can use it. Then next is probe. So, probe are the basically a device or a combination of a device and wire that is used to interconnect the unknown quantity to the instrument. So, it basically connect the unknown quantity that we want to measure to the device at which the instrument at which we want to measure the signal. So, probes are of different type. Generally, probes are used in CRO, but there are some probes that we are using in multimeter also. So, probes are active probe, passive probe, current probe, and apart from this there are more types of probes like a differential probe. There is a different probe that is used for the high voltage measurement, means we want to measure if a voltage of 1000 volt, then we have high voltage measurement probe. So, this passive and active probe. Yes, these passive probes we can use for the low voltage and low frequency. So, up to 500 megahertz we can use a passive probe, and similarly in the voltage approximately we can use passive probe up to 200 volt to 300 volt. But if we use this passive probe for the more voltage, then it will not give the accurate value. So, this is the this is the passive probe. So, in passive probes we know this probe, this is the input of the CRO. So, the CRO input resistance is 1 mega ohm and capacitance is approximately 20 microfarad. So, what will happen, this is the probe input, here we have to apply unknown quantity, and suppose this probe is either is 1:1 probe or 1:10 probe, means 1:1 probe means same voltage is applied at the input of the CRO, and 1:10 means ki the signal is reduced by the 10 times, the amplitude is reduced by the 10 times. So, here we have seen we have shown the 1:10 probe. So, 1:10 probe means suppose the CRO input is here we have applied. So, this resistance is of 1 mega ohm and this resistance we will select 9 mega ohm. So, 1 divided by 9 plus 1, suppose we want to measure the voltage across this because this is connecting to CRO. So, the resistance at the input of CRO will be 1 mega ohm divided by 1 mega ohm plus 10 mega ohm. This is as per the voltage divider rule. Okay. And here this is connected in the form of bridge. So, here it is Z1 Z4 is equal to Z2 Z3. So, it means R1 C1 is equal to R2 C2. So, here the value of R1 is 9 mega ohm and the value of R2 is 1 mega ohm. So, respectively we can select the value of C1 C2, and there is a compensation capacitor. So, by this compensation capacitor we can adjust we can calibrate the CRO also. So, this is the passive probe. Now, active probe. So, when we measure high voltage or we measure high voltage or high frequency. So, at high frequency the capacitance of these active probes work like short circuit, it will short circuited the resistance R1 R2, because the at high frequency the reactance of the capacitance will be 0 or very less. So, for this purpose, for measuring high voltage or high frequency signals, we need active probe. So, active probe mein we are using the BJT emitter follower. So, we know the emitter follower circuit has a property that its input resistance is very high and output resistance is very low and the gain is 1. So, it is the BJT emitter follower basically offer the resistance at least up to 1 mega ohm. And if we want to enhance this resistance, we want to need a high value of resistance, so that our circuit will, our instrument will not affect the measuring circuit, then we need a FET source follower. So, FET source follower also offers more than 10 mega ohm resistance. Similarly, there is current probe. So, current probe depends upon the when we put suppose we want to measure the current of any instrument, then we will put the current at under this instrument. Then what will happen, we know that if there is a change in current in any instrument or the current carrying conductor is there, then it will form an electromagnetic field. So, that electromagnetic field, the change in that electromagnetic field is sensed by this ferrite transformer core, and then that instrument will measure the current. So, here we do not need to put the current which circuit in which we want to measure the current with this. We can just put the current here and it will show this. There is apart from this, there is a differential probe. In differential probe we can measure the difference of two signal. In the differential probe we do not need ground circuit. So, we will just put the probe at the two positions and that will give the difference of the voltage there. The differential probe has a advantage that there is common mode rejection ratio is 0. It means ki it will reject all the signal, all the noise signal that is present in the atmosphere or other things. Similarly, we have high voltage probe. In high voltage probe again the capacitance problem is there. So, high voltage probe, there shielding is provided and we can measure 1:1000 ratio of that signal. So, these are the difference between passive and active probe. So, we know that the active in passive probe we can use for less than 300 volt and all this, and active probe we can measure up to 500 volt. So, these are the basic difference between active and passive probe. That is from my side. Thank you all.